In this lecture, we're going to learn about move constructors. And this is a special kind of constructor that is going to steal data from other objects. And those objects we steal from are going to be temporary objects that are going to be killed by the compiler anyway. Let's look at a simple example. We're going to use a class called point. The class is going to have two member variables x and y, which are pointer to double. So this is going to allow us to see some things we really want to see in this lecture. The class is going to have a constructor and a bunch of other methods that are not shown here because they really aren't important for what we want to see. But let's look at the syntax we use to build from temporaries. Here we have a point object which is being built from another point object. So this would really use the copy constructor, but notice what we are building from. It is a point that we are building in place here. So the constructor is going to be called from what we have in the parentheses here, and we're going to build a temporary point object, whose sole purpose is to be used to build another point object, which is going to be P3 here. So the point of this entire lecture is to not waste the data that we had in this point that we have as a parameter or argument here. We want to grab the data n, and we don't want to go through the trouble to build another point because we already have it as a temporary here, and we want to steal data from it. Okay, so let's try and really illustrate this better. We're going to have a temporary object built somewhere in memory, and it's going to be a full point. It's going to have a pointer to x, a pointer to y, and these are going to be double pointers. The pointer to x is going to have some address, which is ending in D3 here. The pointer to y is going to have another address, which is ending in D4 here. And we're going to have content stored at these memory locations. So this is our temporary. And suppose that what we are pointing to is something really expensive to build. Suppose it is a really heavy object, and we don't want to waste data if we have it already constructed, and it is going to be wasted because the moment we are done building from a temporary, the temporary is going to be thrown away by the compiler, and we don't want to really waste. So what we can do is steal data from this temporary if we are building another object from it. So for example, here we are trying to build P3 from our temporary here. So we're going to grab the data from temporary and steal that and put that in our P3 object. At this moment, when we are building P3, it's going to have these two pointers because these are the member variables we have n, and the x pointer is going to be pointing to null pointer, and the y pointer is going to be pointing to null pointer by default. It's not going to have any content. But we don't want to go through the trouble to put in the content because we already have the content in temporary. So what we can do is steal these pointers and make them stored in P3 here. So for example, we can grab this pointer address and put that here in P3. We can grab this pointer address and put that in P3, the pointer to y. And then after we are done, we can make these pointers in temporary point to nowhere. We can set them to null pointer, and we will have effectively stolen data from the temporary and stored the data in our P3 object. And by stealing data like this, we have avoided the heavy work of setting up our own data in P3 here, and this is really cool. Okay, so if we steal data, we're going to have a case like this. The pointers in P3 and a temporary are going to be the same, but to really completely steal the data, we're going to reset the pointers in temporary, and we're going to set them to null pointer. So in temporary, we're going to have a null pointer, and it's basically not going to be pointing anywhere. It's not going to have any content. The temporary object is not going to have any content in here, and the data will have moved in P3, and this is what we mean by stealing data. So this is all fine and good, but how do we do this in C++? Well, we use a move constructor. A move constructor is a special kind of constructor whose sole job is to steal data from other objects. And this is the syntax you use to set it up. You say the name of the constructor and you pass your parameter like this. You say the class name and then you put two ampersand symbols, and this is going to be your move constructor. When the compiler sees this syntax, it's going to know that it is a move constructor and it is going to use it to steal data from temporaries. So what it is really going to do, we're going to steal the pointer in x. We store that in our object. We're going to steal the pointer in Y, and we're going to store that in our objects here. And then what we need to do is to set the pointers in our temporary to null. And we're going to do that through a special function that we're going to set up in our object, which is going to reset all the pointers. And this is really how you do it. Okay, before we go off and really try this in Visual Studio Code, I want to show you a way we can force the compiler to treat our object as a temporary. And we pass this through a special facility we have in C++, which is called std_move. We need to do this because sometimes the compiler is going to do some optimizations, and it's not going to treat our temporary as a temporary, and it is going to call the copy constructor instead. We want to force the compiler to treat our object here as a temporary, so that's why we pass this through this std_move function, which is built into the C++ standard library. So now that you have an idea about move constructors, let's head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is move constructors. We're going to grab our template files and we're going to put them in place. And we are going to open this in Visual Studio Code like we always do by dragging and dropping here. This is going to open our folder, and we will open the main CPP file and clean it up a little bit. The first thing we want to do is to bring in the class we want to use to learn about this. And we will set up a class called point, as we have seen in the slide. So let's do that. We're going to set up a header file. We're going to say point.h for our header file, and we're going to put in an implementation file called point.cpp. Let's do that. And we are going to put in our class. Let's start by the header file. We're going to put in the class which is called point here, and let's go through it a little bit. The class name is point. It's going to have a few private member variables. We're going to have a pointer to double. We're going to have two variables, x and y, which are of type double pointer, so they are pointers to double. And we have a function we will use to invalidate our null pointers. But we can ignore this for now. We're going to come back to it in a little bit. So this is our constructor. It's going to take two parameters. We have a destructor, which is going to release the memory, and we have a copy constructor here. You see, it is taking the parameter by const reference. Let's say this here, it is a copy constructor. And if we go down, we have a few setters. The first one is going to set x, and it is going to dereference our pointer and put in our value. The second one is going to set y. Again, it is going to dereference and put in our value. And we are doing this dereferencing because our member variables are pointers. We need to go through dereferencing to get to what is pointed to by this pointer. You should know this by now. We will have a few getters. The first one is going to return x because x is a pointer by default. And we're going to return y in getY here. And we have a utility function which is going to print information about our point. So it's going to print the x coordinate of a point, and it's going to print the y coordinate of a point. And here you see that we are dereferencing again because we are going through pointers. Let's be consistent here and put the parenthesis on this x guy here. Okay, this is our header file. I think it is pretty good and pretty easy to understand at this point in the course. So let's do the CPP file. We're going to put in the implementations for our point class. Here we have the constructor implemented. We're going to set up a new memory location because we have pointers in our member variables. We have to initialize them with valid memory. So that's what we do here. We're going to dynamically allocate memory on the heap, and then we're going to store in our data. This is the syntax to do that. We also have a copy constructor, which is going to also allocate new memory from the heap, and we're going to store in data from our source object. Notice that we are doing deep copy here. We're not doing blind member-wise copy, which would be shallow copy. We are doing deep copy because we want to have independent data in our constructed point object here. We also have a destructor which is going to release memory that we have initialized in our constructors, and this class is pretty done by now. Let's go back in the header and really verify this. Our setters are implemented in place, so this should work. Let's close the left sidebar here, and we're going to go back to main. We're going to include our point. Let's say point.h. And then we're going to create point object. So let's, for example, create point p1, and we're going to put in data. We're going to put in 10.0, and 15.0. Why not? Okay, let's do this. And we can print information about this object through the printful member function here. So we can do that. So let's print this information here. We're going to say P1 printful, and we're going to try and build. We want to investigate that things are really working exactly as we expect. We're going to bring up a terminal, and we're going to clear and run rooster. If we do that, we're going to see that in X we have 10, in Y we have 15, which is what we expect here. Let's put in 10.4, for example, and 15.6. Why not? And build again. We want to see our decimal points. The build is good. We can clear and run rooster. And you see that we see the data here. And this is what we expect. Okay, so let's try and create a copy of a point from a temporary. So what we're going to do is say point, and we're going to say P3. And we are going to construct this point from a temporary. The way we do that, we're going to force the compiler to treat what we're going to pass here as a temporary. And to do that, we need to pass this through a facility called std_move, as we saw in the slide. So let's do that. We're going to say std_move, and then we're going to pass our point here. Again, you will have to just believe me here because we need to learn about the move constructors, but we don't have enough tools to really understand what std_move does by now. You can treat as something that is going to force the compiler to treat this point here as a temporary so that we can steal data from it. So you are basically telling the compiler this point is going to be destroyed anyway, so steal from it if you can. This is what we're telling the compiler. So we're going to put in data. Let's put in 20.5 and 5.8, and you can really put in anything. Then we're going to see what happens here. Okay, so we have our call to build an object from another object, but what we are building from is a temporary. Okay, so let's comment out the print information we had in front here because we don't want this to confuse us. And let's see what we have in our constructors. We have a print out in the body of the copy constructor, and we have an std_cout statement in the constructor, which is taking two parameters here. So let's see what happens. We're going to build this and see what we see on the terminal. We're going to build with GCC, and you see that the build is good down here, so we can clear and run rooster. Now we're going to see that we have two constructors called. And now we see that we have two constructors called. I think the first one is to build this point here, and this is going to make our code a little more confusing. So I am going to comment this out, and we're going to build it in. Okay, so the build is good. We can clear and run rooster. We're going to see that we have a constructor called, which is going to build this temporary here. And we have the copy constructor called because it's going to be copying from this temporary. So this is what we expect. If we try to build from a temporary, by default, the compiler is going to use the copy constructor. And that's what we see here. We see that the body of the copy constructor was executed and printed out this message here. And we don't really want to use a copy constructor because a copy constructor is going to do a lot of work. It's going to allocate new memory locations. It's going to copy data. But what we are building from is a temporary, and it's going to be thrown away, and it's going to be thrown out anyway. So why not steal data that we have inside? If you look at our model of the point class, you're going to see that our member variables are pointers. So we can technically steal pointers in our temporary and just steal the data and avoid the work to do all this new memory allocation. And we can just steal data that is already there. This is going to become attractive if the pointers you have in your member variables are pointing to something really expensive. Suppose your member variables is some string that is really huge, and you have a pointer to that, and you don't really want to rebuild a memory location to copy that string into. So we can steal data if we can and avoid all that hard work. And we need to do that through a move constructor. So we're going to go in our header file and set up a move constructor. And we have seen that the syntax for a move constructor is really straightforward. All you have to do is say the name of the class, then you specify your parameter by value. and then you put two ampersand symbols here, and then you say your source point. And then you give your parameter a name. Let's use source point here. It's going to work. And then we're going to implement this in the CPP file. And let's go down and say that we want to do our move constructor. We can copy the code we have for our copy constructor and adapt this a little bit. So we're going to grab that and put that here. And we're going to adapt the parameter to make it a proper move constructor. And let's make sure the names are consistent here. So source point and source point here, they are consistent. And what we want to do in here, we don't want to allocate for a new memory. We're just going to steal the pointer. And what we do is going to say source point get x. This is going to return us a pointer to the memory location in the source object, which is our temporary here. And then we're going to do the same things for the y member variable. So let's do that. We're going to say source point and get y. Let's say this properly. We're going to call the function here. And by this point, we will have stolen the pointers from the source point. But after we do this, why do we have this squiggly line? Do we have more than we need of these parentheses? I think we do. So this is right. Visual Studio Code is happy. So now that we have stolen the pointers, we need to do something more, because at this point, our two objects will be pointing to the same memory locations, and we don't want that. Remember that when a point is destroyed, it is going to release the memory it is pointing to in its member variables x and y. And we don't want the temporary to release our memory, because the memory belongs to us now. We have stolen these pointers. So what we need to do is to invalidate the pointers in a source point here. And we can do that through a special function that we have seen here, which is called invalidate. It's going to invalidate the pointers that the current project is pointing to. So we're going to use this. You're going to see that this is going to set the x pointer to null pointer and the y pointer to null pointer. And we can call that to do our dirty job here. So we're going to do that in the copy constructor. So we're going to say source point invalidate, and we are able to access this method, which is private in point, because we are doing this from the point class. You really need to understand this. Some people might think because this method here is private, we wouldn't have access to it if we called it like this. But please take a look at where we are calling it from. We are in the point class. And in the point class, we will have access to any private members of this class here. And invalidate happens to be a member of this class, and it is private, so we can use it. And now we have our move constructor set up. Let's go down here and say that it is the body of our move constructor. And if we run the code now, the compiler is smart enough to realize that we have a move constructor in our class, and it is going to use it and steal data from the temporary, and this is really cool. So let's prove this. We're going to build and see what GCC says about this. We're going to build, and the build is going to be good. You see, build finished successfully. We can clear and run rooster. Now you see that we are building our temporary here, but we are calling the body of our move constructor. And after we steal from the temporary here, it is going to be destroyed because it's no longer needed, and it is going to be thrown away, and the data is going to be belonging to point 3 now. If we print information in P3, let's do that. We're going to see that we have the data we had in our temporary here, and this is really cool. X is going to be 20.5 and Y is going to be 5.8. Let's build and take into account the printful statement here. We're going to see that the build is good. We can clear and run rooster. We're going to see that our point now is going to have the data that we had in the temporary, but we didn't go through the trouble to set up new memory locations. We just stole what we had in our temporary here. And this is the job that move constructors do. They steal from temporaries. Okay, so this is doing what we want, but I want you to see another trick we can use to really do this in one step and not have to call the invalidate function. What we can do is set up special getter functions which are going to steal the pointer and invalidate the pointer in one go. And the way we can do that is to go back in our class definition, and let's go to where we have our getters. And we're going to put in another set of getters that are going to steal the data and invalidate the pointer. So here we have steal x, which is going to set up a new memory location. It's going to steal x and store that in this new x pointer. And then we're going to invalidate x. We're going to set that to null pointer, and then we're going to return a new x here. The benefit of this is that we don't have to call invalidate in the body of our move function. By the time we steal the pointer, we will also have a chance to invalidate it, and this is going to be pretty cool. We're going to do the same logic for steal y here, and now that we have this in place, we could go in our move constructor, comment the invalidate call out, and then call steal x. We don't want to call get x, we want to call steal x, so we're going to do that. And we're going to call steal y, and this is going to do what we want in one go. So some people prefer to do things like this, but it is a little less self-documenting. So I would prefer to use invalidate here, because when people see this call, they will at least have an intuition that we are invalidating data from the source object here. And this is pretty cool. So we're going to build and really prove that this is working and we don't have any problem with this. You're going to see that the build is good. We can clear and run Rooster. You're going to see that we built our object from a temporary and it is working flawlessly here. We have the data from the temporary and we didn't have to go through the job to build another object. We just stole the data that we had in our temporary here. Please remember to use std move here, because if you don't, the compiler is not going to treat this as a temporary, at least in my case here. And you need to put std move in here to make sure that the compiler is going to treat our temporary here as a proper temporary, and use the move constructor to construct other objects from this temporary here. This is really all I had to share in this lecture. Hopefully you didn't find it confusing. If you have any problems, please do ask and I will do the best I can to help you out. For now, we're going to stop here in this lecture. In the next one, we're going to learn about deleted constructors. Go ahead and finish up here and meet me there.